we'll slow it down for because this is the harder part. 4-3. Properties of logs. You already know two of them. Interchangeability from a logarithm to an exponential and an exponential back to a logarithm. That's a property of logarithms. It's also the definition, but that's irrelevant. The inverse property of logarithms is also a property of logarithms. They're not the main ones, but you know, there's something to keep in the back of your mind. And then there's a couple of weird ones. Log base b of b is equal to 1. Log base b of 1 is equal to, what power do you raise b to get to 1? 0. Those two properties. Facts, I guess you could label them. Then we get into the fun ones. The book doesn't prove them, but I like proving them. We know that b to the x times b to the y is equal to b to the x plus y. Okay. So I'm going to use this fact to prove a few of the laws of logarithms. So, proof. I'll prove it and then write it out as one of the laws. Most people give you the law first and then ask you to prove it. I go backwards. We'll start off with analyzing what happens with this, the log of a product. My guess is it has something to do with the laws of exponents. If you multiply your bases together, you add your exponents. So there's something that has to correspond between multiplication in a logarithm and the laws of exponents, because they're interrelated functions. So let's start off with let m equal b to the x, n equal b to the y. By the way, I can do that. Any number that I want, as long as m is positive and n is positive. If you have an exponential function, and I choose some value m up here, it corresponds to a point on the graph. That means it has to be, in this case, b raised to some power corresponds to that point. And this thing would be x, b to the x. So that's totally legal to say that m is equal to b to the x and n is equal to b to the y. All right, so I can do a little substitution here. Log base b of b to the x times, that's replacing the n, replace the n with b to the y. Okay. We already said that b to the x times b to the y is equal to b to the x plus y. Hold on, brain fart. I lost myself someplace.
I got a question. I do log b mn equals log b to the x times b to the y.
Oh, here?
Yeah.
I'm choosing a substitution. Whatever m is equal to, I can find some exponent on the base b to equal it. That's what this graph was describing. If this is n, right, whatever n is, it's a positive number. There's a corresponding point on the graph. That means there's a value that I can raise b to get to n. So it's just a substitution. So I said let n equal b to the x and let n equal b to the y. I can find x and y such that it's true. Once I get to this point, log base b of b raised to the x plus y. What happens to the log base b and the b? They kind of cancel. I said we use the word poof because they're inverse functions. The log base b and the b2 though go poof, and you're left with x plus y because of the inverse property. It's technically this one right here, where the log base b and the b kind of cancel, and you're left with the domain part, which is in this case just x, but in that case x plus y. So I guess then I have to kind of go back to my substitution. If I have m is equal to b to the x, I want to solve for x, but it's in exponential form, and I don't know how to solve for x when it's up here. So what is another form I can put this in if I don't like exponential form? How do I write it as a logarithm? Start off with log b base b of m is equal to x.
So that's loggy froggy, right?
It's loggy froggy, but my way. I don't do elementary school. Yeah, it's
You
cute.
never heard of loggy the froggy?
Yes, I've heard of it. Yeah, he's old. So the other one is n equals b to the y. So how do I change it into a log? Well, that'd be log base b of n is equal to y. So I can replace x and y with log base b of n plus log base b of n. And it gives us our first law. Bring this down. Log of m times n base b is equal to the log of their factors. So it allows you to take a logarithm of a product and expand it out into smaller pieces. Why do we need to do this? Well, if you didn't have calculators and you had to use tables, that was the only way to get to the tables so that they would work properly. Other than that, we use it to simplify. For instance, if you have log of 100x, you can't leave that, because 100 is a perfect base 10 logarithm. So because this is a product, you're going to write it as log of the first number plus log of the second number, and expand it out. So it becomes log of the first factor plus log of the second factor. What's log of 100? 2. So this becomes 2 log x. So that's called simplification. It's like you can't leave square root of 8, you have to write it as 2 square roots of 2. Same thing with logarithms. So if you have something like log of x, y plus 3, how would this expand out? Now remember, this is very cautious. This law only works on multiplication. It does not work on addition and or subtraction. So this y plus 3 is irrelevant. That's a single number, y plus 3. So it's log of x plus log of, and you have to keep it in parentheses, y plus 3. It's the best you're going to get out of it. You cannot separate log of y plus log of 3. That doesn't make any sense. How about log of x times y times z plus 7? Does it work on 3 terms? The answer is, well, yeah, why not? I mean, you could separate it into 2 pieces. You can say, do it in those 2 pieces. So it would be log of x times y plus log of z plus y, z plus 7. And then the x plus y can get separated as the log of x plus log of y. So basically, anytime you see a times, it turns into a plus, as long as you put log in front of the next term. So it's log of x plus log of y plus log of z plus 7. And that's called expanding with the first law of logarithms. Multiplications become additions as long as you put logs in place of it. I remember you all yawning so much at the beginning of the semester. We still have 15 minutes. Oh. Did she say?
No, she said shoot. I was saying shoot.
I thought you couldn't hear.
I can hear perfectly fine.
You have selective hearing.
I have very selective hearing. I hear curse words, and Mr. Cloran is a jerk. I hear things like that. Now you're all talkative. This is awesome. All semester long I've been looking for this, and now you're like, a little late. Law number 2, I'm just going to write it down. The proof is identical. It kind of works on this one. B to the x over b to the y is equal to?
bx plus y?
Definitely not plus.
Minus.
X minus y. So if you have the log base b of m divided by n, this equals, take a guess, the product became pluses, the quotient's going to become minuses. So it's log base b of the first one, n, minus log base b of the second one. Simply put, if it's in the top of a fraction, plus. If it's in the bottom of a fraction, minus or negative. All right, let's put them together. Do both of them at the same time. What if I have log base 2 of, pick a good number, 16 xy divided by z. Log base 2 of 16 xy divided by z. Now, putting the two rules together, you just have to think of it as, if it's a multiplication and it's in the top, everything's going to get separated with a plus. If it's in the bottom, it's going to get separated with a minus. Notice the log base m was positive, but the log of n was negative because the n was in the bottom. Log 2 of 16. Log 2 of x. Log 2 of y. Minus log 2 of z. Because the z was in the bottom, he's the only one that gets a minus. Does that make sense? What's log base 2 of 16?
No, I'm going to be honest with you.
What's log base 2 of 16? 4. You have to replace it. You can't just leave it like that. So I'm just going to cross it off and put a 4 here. So technically it becomes 4, not log of 4. It's just 4 plus log base 2 of x plus log base 2 of y minus log base 2 of z. All right, what if I flip it around? Make it a little weirder. 8y over xz plus 3. I know, they're so easy, but they're also easy to screw up. Remember, things in the top become plus, things in the bottom become minus. You can only separate products, quotients, not pluses and minuses. So the first one is log base 2 of 8, which is 3.
Oh, I'm sorry. My
2 to the
bad.
third, 2
I
to the
slipped.
third.
I slipped.
All right, what's the next one?
Log base 2 of y.
Plus log base 2 of y.
Minus log base 2 of x.
That's not the answer. Minus of z plus 3. Because it's in the bottom, it gets a minus. Even though these two are multiplied together,
that kind of threw me off.
because it's in the bottom, it's minus. Keep the rules simple and life is a lot easier. That leaves us to the most important law. Those two are nice, but the next one is actually used 10 times more. What if I have log base b of x cubed? Well, that's the same thing as log base b of x times x times x. Because I don't know what to do with exponents, but I sure as heck know what to do with products. So what's log base b of x times x turn into? Well, no, you don't just write x plus x plus x. You're forgetting the main feature up here. Log base b. Log base b of the first x n plus log base b of the second x, this one, plus log base b of the third x, this one.
Do we have to, can we just pull the three?
We're getting there. People.
Yeah.
If you take 5 plus 5 plus 5, what's it equal to? 15. What's an easier way of writing that problem? 3 times 5. That's what multiplication is all about. It's multiple additions.
So that'd be 3 log b x.
There's 3 of these log base b of x's. So if you analyze this a little bit, the exponent up here was 3, and that number popped out front, kind of just dropped. So the last law of logarithms, the most important one, is this. A couple stars. Log base b of x to some power is equal to that power times the log base b of x. Couple stars. That one is super important. That one will solve so many equations. For instance, wait. Where is that? We didn't do 2, we did 3. 3 to the x is equal to 20. Remember this equation? I'm going to apply a function to both sides. Kind of like if you had the square root of x minus 1 is equal to 2. How did you solve this equation? You squared both sides, right? If you had x minus 1 all squared is equal to 4, what would you do to both sides? Square root it. You would apply a function to both sides of the equation. Well, I'm going to apply a function to both sides of this equation because I don't like where the x is. I want the x to be down. So the function I'm going to apply is ln. Now, I could choose log, the regular common base log 10. I like ln for one reason and one reason only. Does anybody know what it is? What is it? What do you say?
Thought you can hear that.
No, I couldn't hear that one, but what did you say?
No.
It might have actually been the right answer. LOG is 3 letters, LN is 2. I'm lazy, I go with the 2 letters. But if you want, you can do LOG to both sides. That won't hurt anything. What? I have to find out what you said now. 3 to the x is still there, 20 is still there. 3 to the x is still there, and 20 is still there. This law of here says I can take the power and drop it down out front. Well, what's the power on the 3? X. So I can drop him down out front. So you get x ln of 3 is equal to ln of 20. It's not 3 anymore, and it's not 20 anymore. It's like square root of 3 and square root of 20. They're different numbers. How do you solve for x? Ln of 3 is a number. How do you solve for x? Divide by ln of 3. You never divide by the variable you're trying to solve for. So you divide both sides by ln of 3. And you get x equals ln of 20 divided by ln of 3. ln is on your calculator. You can type this in. It'll give you an answer. Approximate answer, but it'll give you an answer. So what's ln of 20? Don't forget to close the parentheses over ln of 3. Or you could do log of 20 over log of 3. It'll give you the exact same answer, which is kind of cool if you think about it. You can tell me the answer. Now, 5 be
I have a calculator.
yeah. Math class, cell phone calculator. Does it even have log on it? Does it even have ln on it? So tell me the answer.
I got 2.72.
2.72 approximately? 2.72. Now, what is that saying? Well, it's saying that if I take 3 and raise it to 2.72, the answer better be really, really close to, remember it's approximated over there, so it's going to be really, really close to 20. So what's 3 raised to the 2.72? 19.9, which is really, really close to 20. Now, the more decimal places you absorb into your answer, the better your approximation is going to be for the right result. But it's kind of a neat little process that we can actually find the power you have to raise 3 to get to an answer of 20. The exact answer, of course, is ln of 20 over ln of 3. The approximate answer, 2.72. Isn't that neat? Now we can do worse problems. How much time do I have?
5 minutes.
5 minutes? Liar.
7.
7?
No, get out at
8:30.
Oh, we
No, we don't.
8:20.
8:20. We'll go with 8:20.
We're gonna be really special.
Oh, that's on those. Don't try to set me up.
Y'all beat 'em up
Man,
every
it's
time.
too
There we
freaking
go.
many here for me to get messed up. Come on.
Last example. It's not going to be pretty, though.
Every day's with you.
That's 16.
Mm-hmm. Oh, I'm sorry. 2 last examples. This is one. This is expand. I still have to do a contract. I'm sorry, I forgot about my second one. There's a second one. Life goes on. So, log base 2 of all this mess. And I want to expand it. Basically, that means I don't want any more multiplication, I don't want any more division, and I definitely don't want any powers. Those all have to kind of get absorbed in my expansion. Same rule applies, but you've got to be a little careful now. Powers are there. And if powers are there, we want to bring them down up front. So this one's going to have multiple breakdown points. It's not going to be as easy as separating multiplication division, the first few examples that we did. This one we're going to have to take apart chunk by chunk. And the chunks in this case are top and bottom. So separate them in top and bottom and then start dealing with them individually. So when I separate them, it's going to become log base 2 of the top minus, because it's in the bottom, log base 2 of the bottom. And at least now it's 2 separate problems you have to deal with rather than one huge ugly problem. Now, little point of caution. This negative gets applied to everybody to the right. So if I start separating inside here and it has a plus, eventually it's going to turn into a minus because it's in the bottom to begin with. They all get minuses. All right, so what can I do with this first one? What's holding me back from doing anything? What can I change the square root to? See, this law only works on powers. It doesn't work on roots. So how do I change a square root into a power? In other words, if I want to write the square root of x as x raised to some power, what is that power?
Oh, yeah.
Say it again.
1.
1/2. It's a half power. If I have a cube root of x and I want to write it as x to a power, it would be
-3.
1/3. 1/3. So square root is what power?
Third.
A half. Square root, not a third root. Half. So I'm going to take that half power and bring it out front. So 1/2 log base 2 of 16x cubed y plus 1. One piece at a time. All right, minus bracket. Anytime you're dealing with minus signs, you have to be really cautious over groups. What can I do to the second part? What can I separate? Can I bring the power down out front?
No.
Why? It's only on the z. It has nothing to do with x plus 4. So I can't touch the power yet. So what's the other operation I can deal with? There's only one operation in here. Multiplication. It's right here. Times z. So I can write that as log base 2 of x plus 4. And since it's multiplication, this becomes plus log base 2 of z to the 3/2. All right, what can I do to this part here? How many multiplications do you see? 16 times x cubed times y plus 1. So there's 3 pieces, 2 multiplications. So this becomes 1/2 bracket. That 1/2 affects every little piece on the inside. So it's going to be log base 2 of 16 plus
Log base 2 of x cubed.
log base 2 of x cubed plus
Log base 2. Yeah.
log base 2 of y plus 1 bracket minus bracket. Let's leave him there for a little bit. I can't do anything with that first one, right? Can't separate over pluses. What happens with the second piece? Take that 3/2 and put it out front. So it becomes plus 3/2 log base 2 of z. We're done with that one. Well, almost done. It still has to get that negative, but we're almost done with that one. We're not done with this one. We're not done with that one, and this one needs a half. So what's log base 2 of 16 equal to? 4. I'm just going to cross it off and put a 4. What happens to the 3 with this log base 2 x cubed? What happens to this power of 3? It gets dumped out front. It just moves, literally moves out front. So what's 1/2 of 4? 2. Plus 1/2 of 3 log base 2 of x. But 1/2 of 3 is what? Please don't give me a decimal. 3/2. Or 1.5 if you really want to be boring. Log base 2 of x plus 1/2 times log base 2 of y plus 1. 1/2 log base 2 y plus 1 minus log base 2 of x plus 4 minus 3/2 log base 2 of z. Is there any multiplication left in that expression? No. Any powers? Nope. Any division? Nope. That's when it's totally expanded. Those 3 things are totally gone. All that's left is numbers times logs, and pluses and minuses. That's it. And that's what you want. No powers, no multiplication, inside a log, and no division. And I don't have enough time to show you the contraction, but those are actually easier. No. Okay. Let's do another one that's going to show up on the test, and it's going to show up in the final. And it's actually a very easy problem. So for instance, maybe I should write the laws down first. Really quickly, the laws. 1, log, and I'm not going to put a base, mn is equal to log of m plus log of n. The log of a product becomes the sum of their logs. And you can go, remember equal signs, you can go both directions. If they're together, you can separate them. If they're separated, you can bring them together. So it goes in both directions, even though most people read it left to right. 2, the quotient rule 1, m over n, is the log of the top one, keep it positive, minus the log of the bottom one. The bottom ones always become minus. However many factors are in the bottom, they all get a minus sign in front of them. And the more applicable law is number 3, log of m to some power is equal to the power times log of m, which helps us solve a lot of logarithmic equations. All right, so if I want to go the opposite direction, I have this expanded version of logarithm, and I want to go in the opposite direction. What you're trying to do is combine all your logs under a single logarithm. You're only going to write log one time. So one step at a time, deal with the numbers that are sitting up front. The 2, the 1/2, don't bother with the sign, just take the number, 1/2. And this one just has a 1, so we're pretty safe with that. Take those and bring them back as powers, because that's where numbers came from out front. They were originally a power over here. So yank the 2 back up in its place, and you get log base 3 of x minus 1 squared minus. What happens to the 1/2? Dead fish. Now, most people don't know that, and I was going to get to that. You take the power and you bring it up onto the y, and it becomes log base 3 of y raised to the 1/2 power. And then the last one, nothing you can do to it, so just log base 3 of z plus 3. Okay? Now, let's talk about it. What's a half power? It's a square root. Now, it's your choice. If you want to write it as the square root of y or leave it as y to the 1/2, I could care less. I personally switch it to square root. It looks better in the final answer. But if you want to leave 1/2, I'm not going to mark it wrong. All right. Now, this is the trick. If it's positive, the factor stays in the top. If it's negative, the factor goes to the bottom. This is the place where you can write it as a single log. So you go log base 3. You create a top and a bottom only if you have a negative someplace in there. If they're all positive, they're all going to go in the top, and you're not going to need the bottom. So what's the positive parts? What factors would I put in the top? What is it? X minus 1 squared will go up here. What else? The z plus 3. And depending how you want to write it, the negative one just goes in the bottom. And the only one that has a minus in front of the log is the y to the 1/2. I'm going to write it as the square root of y. You can write it as y to the 1/2. It's not going to hurt anything. And that's it. You've condensed this problem into one logarithm. Not that bad, right? Most people find this kind of easy as long as they keep their brains straight. They can get a little, no, they can't get any harder than that. They're pretty easy. How about 1/3 log base 2 of x plus 1 minus 1/2 log base 2 of y minus 1/4 log base 2 of z minus 1. Getting all powers this time. Now, depending on if you want to shortcut this or not, if you don't want to write the next line down with the powers up, what you can do is just kind of go and put the powers up mentally. These powers go back into those positions. So it really is log base 2 of x plus 1 raised to the 1/3 power. Do you want me to write it? I can. It's not a problem. Log base 2 of x plus 1 raised to the 1/3 power. It's not times 1/3. It's raised to the 1/3 power. Anything in the front becomes a power. Minus log base 2 of y to the 1/2 power. And then minus log base 2 of z minus 1 raised to the 1/4 power. Once you get those powers up, the next step is write one logarithm. Don't write it anymore. I've seen people write log of log, and you don't ever want to see two logs next to each other. So you write one logarithm, log base 2. If it has minuses, create a fraction to give yourself a top and a bottom to work with. Oh, and I thought you weren't coming tonight.
You want me to go?
Oh, if you wish.
No.
It's an
I
open
need
door
to go.
policy. Come on in and leave. I don't care. No, you're all right. I just didn't think you were coming this late.
I apologize.
All right, so the positive ones stay in the top. Which one's positive? Which factor would stay up top? X plus 1 to the 1/3. Leave off the log. You don't want the logs anymore. He's being replaced here. So this becomes x plus 1 raised to the 1/3 power, or the cube root of x plus 1, depending on how you want to write it. All right, is there any other positive factors I could put in the top? No, so the other two have to go to the bottom. So what goes in the bottom first?
Base 2.
Do I want to write log base 2 down here?
No.
No, what do I want to write down here?
Square root of y.
Okay, we can write it as square root of y. Times?
4 for z.
We want to write it as the fourth of z minus 1. Now we got mixed notation. That's a little weird, but I can live with that. Now, the book might not have that in the back as the answer. They might actually have this. Can you rewrite it? Log base 2 of x plus, well, let's write the cube root of. The cube root of x plus 1 over the square root of y times z minus 1 squared. That's what the book would probably have. It's a simplified version of the other one. So how did I go from the left-hand side to the right-hand side? I think I did that right. No, backwards. The square doesn't go here. Put it here. And it's not a square root, it's a fourth root. There. The book would probably have that. When you do the fourth root of y squared, what does it become? Think about this. The fourth root of y squared is the same thing as y squared raised to the 1/4 power, which is y to the half, better known as square root of y. And then when you take the fourth root of z minus 1, you get your fourth root of z minus 1. And it works out fine. So they take the radical and make it one radical rather than two separate ones. So if you see it, you can always break it apart and simplify if you want. But that's rare. That's rare. on the test. I love this problem because it's actually not that hard, and it tests if you really understand what it means to do all this mess. This is the way I learned how to do logarithms. The tables would tell you certain values of the logarithms, and then they would give you a log of some kind of ugly number, and you had to expand it out just to figure out what the answer was. So this problem I designed to force you to do it the old-fashioned way. So you start with this piece, the log base b of 9, I don't know why I put a 2 there, square root of 5 over 8. I think it changes it in the problem to cube root or fourth root or something like that. So you expand it out. So what happens to the top pieces? Well, they become logs that are positive. What happens to the bottom piece? Well, it becomes a log that is negative. All right. And then you expand it out. So whenever you see multiplication, you change it into addition. Whenever you see division, you change it into subtraction. All right. Or if it's in the bottom. So it becomes log base b of 9 plus log base b of the square root of 5 minus log base b of 8. Now, if I told you what b was equal to, you could use your calculator to actually figure out the answer because these are true log solutions. And that's why I left it as plain old b so you couldn't figure it out. All right, now the problem is this. These have a 5, a 3, and a 2, and I don't see any of them except for maybe the 5. So what you have to do is kind of force the issue to create just a log of 3, just a log of 2, and just a log of 5. So how do I make 9 a 3? Or, what is it?
3 squared.
3 squared. So you go log base b of 3 squared. That gets you started at least. Gets you that 3 base, that 3 number. What can I do with the square root? What power is it? 1/2, right? So it's log base b of 5 to the 1/2 power minus log base b. What can I do with 8? I can't make it a 3, can't make it a 5, only leaves me 2. So how do I make an 8 a 2? 2 to the third. Okay, halfway there. So you create the bases that are necessary. What can I do with the powers? Move them to the front. So this becomes 2 times log base b of 3 plus 1/2 log base b of 5 minus 3 log base b of 2. Now you got it in the proper form that we can actually work with. And the rest of it is just substitution. Where you see log base b of 3, you replace it with 0.46. Where you see log base b of 5, you replace it with 0.67. And where you see log base b of 2, you replace it with 0.29. So it's just a simple substitution. So you get 2 times 0.46 plus 1/2 times 0.67, oops, 67, minus 3 times 0.29. Type it in your calculator and get an answer. I have no idea what it is. What is it? Stop looking at yourself. You want me to talk to him?
If he keeps making it so long, maybe I will stop calling.
There you go. Did anybody get the answer here? No calculator?
Mm-hmm. Yeah, other people, they got
Oh, you're going to let them do the work. I see, I see. You're the manager. Sit back, do nothing, let everybody else do the work. What'd you get for 2? Well, someone. Ah, no fun. I don't know. I didn't do it. Is it 0.92?
I got 0.385. Yeah.
0.385? You probably forgot the minus. 0.385.
Oh, they went on and added everything.
Well,
Slow.
yeah. Oh,
I
you were
tell you
doing
I
it
was slow.
piecemeal? No, don't do it piecemeal. Type it right in your calculator. 2 times 0.46 plus 1/2 times 0.67.